All right. So yesterday we spoke about Nexus, guys. We had spoken about what is the concept of Nexus and why do we use Nexus operating system. So anyone who would like to answer this question, like why did Cisco came up with the product of Nexus and what is different in Nexus as compared to your regular iOS XE images? Yes, guys. What is the difference between Nexus OS operating system and the regular iOS XE that we have been running on the switches and the routers?
This OS is more, flexible, open for automation, right? And API calls we can do, and it is more secure than what regular iOS provides. And the Nexus hardware is more capable of handling the faster switching, high throughput as well.
Mm-hmm. Okay. Anyone else?
Yeah, early days, I think servers were using Ether channel and storage were using fiber channels. So Cisco came with the solution of combining both in a technology in the Nexus, so that now we
Mm-hmm.
can use it for irrespective of what is there in the and what is there and connected in that switch. So that's how the Nexus concept
Right.
and switch came.
Right. So basically, the concept of Nexus operating system was to actually have one single device which can run Ethernet and fiber channel. I can see the answers on the chat as well. That's right. So basically, the concept of an Nexus operating system was introduced so that we can have Ethernet and fiber channel running into one single box. So earlier when there were like traditional operating systems running in, the traditional operating systems were only supporting Ethernet technology, where Cisco wanted to club Ethernet and fiber channel into one single box. So that's where they came up with the concept of Nexus OS, Nexus operating system, right? And with regards to Nexus, I told you guys we have right from Nexus 1K onwards. We have Nexus 2K, we have 3Ks, 4Ks, 5Ks, Nexus 6, 7, and 9K, right? So we have entire range of series coming in with Nexus operating system. Just excuse me, guys. I'm getting a call from Mr. Sushant. Give me 1 second. Start with the hardware of Nexus 9K and Nexus 7K, guys. Let us start with the hardware of Nexus 7K first. Now, for Nexus 7K and 9K, if you guys are able, I actually told you guys that Nexus 9K and Nexus 7K are the core switches, which are designed for your data center infrastructure. So basically, when I say core switches, it means that they are going to be placed on the core layer in case of your three-tier architecture. So if you're having a data center infrastructure where you're designing the network in a three-tier hierarchy, then you'll be having access layer, you'll be having distribution, and you'll be having core. So Nexus 7K and 9K were actually designed by Cisco to be able to be placed at your core layer. And if in case you are using a two-tier architecture where you're using aggregation and you're using your core, then again your Nexus 7K and 9K will come at the core layer, right? Or you can call it as collapsed core architecture, where you have access and you have aggregation. So if you have a collapsed core architecture where you are clubbing your core and distribution and making it look like one single layer, then it will be aggregation layer where you will be placing your Nexus 7K and 9K. And if you are having a three tier, then it will be coming on the core, right? So first we are going to take a look at the hardware of Nexus 7K, guys. Nexus 7K would be basically has got two different product families. So we have got Nexus 7000 series and we have got Nexus 7700 series. So Nexus 7K can be bifurcated into two different categories. We have Nexus 7000 series of switches and we have Nexus 7700 series of switches. Again, in Nexus 7000, we have got different models. So we have got Nexus 7004, we have got Nexus 7009, we have got Nexus 7010, and we have got Nexus 7018. So we have got four models in Nexus 7000 series of switches, which was the first product from the product family point of view. So first Cisco came up with Nexus 7000 series of switches. And then they also came up with 7700 series of switches in 2016, 17, you can say, where they introduced 7702, 7706, 7710, and 7718. right? So overall, we have like 8 different models of Nexus 7K 7000 series of switches, right? Let us take a look at how does it exactly look like. So if I just go in Cisco Experience Catalog, and here if we take a look at the different models of Nexus 7K, so let us go and switches 7000, 7004. So that's the very first model of Nexus 7K, guys. That's Nexus 7004. So if you take a look at Nexus 7004, this is a modular switch. So if I open up the front cover, you will be able to see the different kinds of modules we have on this particular box. So if you take a look over here, we have got like 4 different slots. We have 4 different slots over here. Are you guys able to see my screen? I can see on the chat window, Ravi has said it. He's not able to see my screen. What about others? Are you guys able to see my screen?
Yes, we can.
All right. All right. Thanks. So it is only for Ravi. All right. Right. So we have got 4 different slots over here, guys. You can see we have Nexus 7004. So because it says Nexus 7004, it means we are having 4 slots. So I have slot number 1, 2, 3, and 4. Now on each and every slot, we have got different kind of line card, or you can call it a different kind of module, right? So because Nexus 7000 is a modular switch, when I say modular switch, we have got multiple slots, and in each slot, we will be inserting a particular module. So what are the different types of modules that we have on Nexus 7004? That's the next question. So can anyone tell me the different models we have opportunity to work on CAT 65? What are the different kinds of modules we have on CAT 65? Anyone?
Supervisor, line card.
All right, I can see. Oh no, I'm not asking.
Fabric module.
So usually in Cisco 6500 series, right? So we will have a wireless engine card and some few service engines as well. You can place in the line card. Service cards we usually say. Akash, there is no voice. You're
Okay, am I audible now?
Yeah,
Yes,
now
you
you are audible.
Sorry for the trouble, guys. It looks like there is some problem with internet. My internet looks pretty stable. Okay. All right. So what I was saying is, just like on Catalyst 6500, we have supervisor module, we have IO module, we have firewall module. Similarly, on Nexus 7K also, we have got different types of modules. Okay. So on Nexus 7K also, we have got different kind of modules. Now, on Nexus 7K, the modules can be categorized into 3 types. So there are 3 bifurcations of Nexus 7K modules. We have supervisor module, we have IO module, and we have fabric module. So there are three types of modules that we have on Nexus 7000 series of switches. That is supervisor module, IO module, and fabric module. Let us try to take a look at the different modules. So 7K module types are supervisor module, IO module, and fabric module. Now, the first one we have in the category is your supervisor module, right? The first type of module we have on Nexus 7000 series of switches is your supervisor module. Supervisor module on Nexus 7K. So, first question, like, what is the use of supervisor module, guys? Why do we have a supervisor module in a switch? Why do we have a supervisor module in a switch, guys?
Act as a control plane.
Act as a control plane. Okay. Anyone else?
Management plane.
That's right. So your supervisor module basically will be acting as a control plane and a management plane for the switch. So from your supervisor module, you will be able to basically do the configuration and management of the switch. So whatever configuration needs to be pushed, whatever out of band management services needs to be enabled, all of these will be done by your supervisor module. At the same time, your operating system is also going to run on your supervisor engine. So if your supervisor engine fails, if your supervisor engine fails, then gradually your operating system is also going to go down. Your switch is going to get crashed, right? The supervisor module is basically the one which is responsible for the up and running of the chassis. It's kind of brain of the chassis. You can say if brain goes down, then the entire switch goes down, right? So in Nexus 70, we have got like different kinds of supervisor engines. We have supervisor 1, we have SUP 2, we have SUP 2E, and we have SUP 3, right? So there are like 4 different types of supervisor engine in your Nexus 7K switch. That is your SUP 1, SUP 2, SUP 2E, and SUP 3. Now, what is the difference between these supervisor models and what is the use of them? What's difference exactly? We are going to look at that in the later part of the class when I come to the topic of VDC. However, as of now, if you want to take a look at the differences, we can do one thing. So what I can do is probably we can just quickly go and type on Google Cisco Nexus 7K compare models. And here we can see the hardware specifications. So we can take a look at the hardware specs of the supervisor engine. What's the difference from the hardware point of view? And apart from that, if you take a look at this catalog, so here you can see we have got the supervisor engine on slot number 1 and slot number 2. So on slot 1 and slot 2, I have 2 supervisor modules. And if I try to zoom in, I will be able to see the different kinds of interfaces we have on the supervisor engine. So if you take a zoom in, you can see we have a console port, we have a management port over here, right? So there is a console port, there is a management port, and there are a couple of USB ports on the supervisor engine, right? So when you say supervisor module is basically the one who is giving you console access, who is giving you out of band management access. We have a couple of USB ports to upgrade the Nexus OS operating system, right? That's the supervisor engine, and these are the 2 slots which are dedicated slots for entering your supervisor engine. And if you take a look at the differences over here, guys, so these are the 4 different types of SUP we have. We have SUP 1, SUP 2, SUP 2E, and SUP 3E, right? So we have got in total 4 different types of supervisor module. Okay.
Yeah, excuse me. Just a quick question.
Yes.
Yeah, I will send the link. I just want to confirm, is this the correct class for DC version 3 for CCIE?
Oh, yes, Zia, that's the right link. And we are in middle of the class. I have just started with the hardware of Nexus 7K. So that's
Okay.
what I'm currently explaining.
Okay. Thank you. Thanks.
Right.
Continue, please. Thank you.
Okay, there's a question in the chat window. Oh, my voice is breaking in between. Is it, Amit? I'm really sorry for that. I hope it's fine now. I had some internet issues in between, I think so. That's the reason I was breaking up in between, maybe. All right, so the 4 different types of soup, guys. We have soup 1, soup 2, 2E, and soup 3E. And the differences over here. So you can see we have
Akash,
64.
you're still breaking.
Oh, I'm still breaking. Give me 1 sec. Am I breaking for everybody, or is it for some of you guys? All right. Okay, so differences, guys, over here. You can see on soup 1 we had 8 GB of memory. Now this was the very old supervisor module, and it's actually kind of end of and now you cannot say end of life because Cisco does provide support on soup 1, but you can say the customers do not invest on soup 1 anymore because of less amount of memory and the clock speed. So typically in production, what you're going to see is you're going to see supervisor 2E for Nexus 7000 series of boxes, and you're going to see supervisor 3E for Nexus 7700 series of boxes, right? So a typical Nexus 7K switch would be either having a SOUP 2E or SOUP 3E in the production environment, right? So, and from the slot point of view, if you see the model that I'm currently on, I'm on Nexus 7004. So on this particular slot, we have slot 1 and slot 2, which are reserved for supervisor engines, right? Similarly, if I go on some other box, let us say I go on Nexus 7018, which is a giant. So if you take a look at Nexus 7018, here the supervisor engine is inserted on, front door height. Here the supervisor engine is inserted on slot number 9 and 10, right? So on this particular model of Nexus 7K, we have got 18 slots. The model itself says 7018. So we have got 18 slots, out of which slot number 9 and slot number 10 are reserved for supervisor engine, right? So depending on the model of the Nexus 7K chassis, the placement of the supervisor engine is done. How you can try to remember this? Maybe an easier way is to just divide the model number by 2. So if I divide 7004 by 2, I'm going to say the last digit over here. So you can divide 4 by 2. The answer you get is 2. So the supervisor engine comes on slot 1 and 2. If you divide 7009 by 2, 9 is not divisible by 2. So again, it's 1 and 2. If you divide 10 by 2, 7010 by 2, so it's 5, slot number 5 and 6. 7018 divide by 2, slot number 9 and 10. So that's how you can easily remember on which slot the supervisor engine gets placed in case of Nexus 7000 chassis. Similar is for 7700 series as well. So if you divide 7702 by 2, you get 1. So you have only 1 soup in this particular model. If you say 7706, it's divisible by 2, slot number 3 and 4. 7710, you get slot number 5 and 6. 7718, slot number 9 and 10, right? So for every model of Nexus 7K, you can simply divide it by 2 and you will get the slot number on which you are going to insert your supervisor engine, all right? And if I take you to 7700 series, guys, there's a small difference over here. Probably you guys can answer it. So if I show you 7700 series, and if I open up the front cover, here the supervisor engine is over here on slot number 3 and slot number 4. So can anyone tell me the difference over here from the previous model of 7K which we saw? So if you take a look at this model, we have got slot 1, 2, 3, 4, 5, and 6. We have got 6 slots. This is 7706.
Third slot, the supervisor.
Okay. Third slot, so it's like both the
Half
slots
size.
are considered as different. Yeah, it's half width. That's the answer. So the difference over here is in 7700 series, what Cisco has done is they have made the supervisor engine as half width. So in one single RU, in one single rack unit, you have 2 slots and you have 2 supervisor modules inserted, right? So that's the difference between 7000 series and 7700 series. Here we are using full width supervisor module, and in 7700 series we have half width supervisor module. Is that clear to everyone, guys? So supervisor engine is the brain of the chassis where you're running your control plane and your data plane, and from where you're going to configure and manage the entire switch. If supervisor module goes down, then the entire switch will be down. For redundancy purposes, we always go with redundant supervisor module. So for sake of HA, we always go with 2 supervisor engines. One would be active and the other one would be standby. Is that clear to everyone, guys? Any questions on Supervisor Engine before I proceed to the next module? Does anyone have any questions? I'll just pause for 5 seconds to see any questions, if any.
Yeah. Just one question. Obviously, the new exam, if we're covering the criteria for the DC V3, it's all 9Ks. So I can understand you're covering 7Ks here, but I just want to clarify: are you going to cover the 9K switches as well?
Yes, of course. So it's not just 9Ks. It has got 7Ks as well. So
Okay.
we have just started with 7Ks, and after this, I'll be jumping on to 9K.
Okay, so the current lab exam for V3 has 7Ks, 7 and 9Ks.
As per the CCI blueprint, yes, that's right.
Yeah.
We do have
Okay.
7Ks and 9Ks.
And will you be covering? Obviously, I guess you're going to cover what criteria needs to be covered on the 7Ks, or like configuration wise. But is that
we will be covering the technology part as well.
Okay, excellent. Thank you.
Right. All right, just in case for some of you guys who were not available yesterday for day 1 of the discussion class which we had yesterday, maybe you guys can quickly take a look at the blueprint that we have gone through in the yesterday's session with regards to the topics which are going to be covered. So if you just go on Netmetric Solutions, and if you take a look at the syllabus that is given on right over here on the right side, I'm sorry, you'll be able to see the topics which are going to be covered in this training. So we have just started with the hardware today. That's the hardware of 7K and 9K, and then we are going to proceed as per the syllabus that is being discussed and presented over here, right? All right, so coming back to the 7K, guys, that's about the Supervisor Engine. The next module we have on Nexus 7K is the IO module, right? The second type of module we have on Nexus 7K switches is the IO module. Now, IO modules are again categorized into 2 types, M line cards and F line cards, right? So we have M and we have F line cards. There are 2 categories of IO modules for Nexus 7000 series of switches, M and F. The difference over here is that M line cards were originally designed by Cisco as a layer 3 line card, and F line cards were originally designed by Cisco as a layer 2 line card. So if you were supposed to use your Nexus 7K switch for layer 2 switching only, then you could have just bought F line cards and you could have saved a bit of money on that part. But if you were supposed to use your Nexus 7K for layer 3 functionality only, then you could have invested on M line cards, right? That's what Cisco had thought initially when they came up with the product of Nexus 7K, and they introduced 2 different categories of line cards. But gradually, so what Cisco saw was that customers were not quite happy. The partners were not happy about having 2 different kinds of line cards just for the purpose of sake of layer 2 and layer 3. They wanted to have one single line card which could do both the functionality. And that's where they introduced F2 line cards. So again, in M and F, we have bifurcations done. We have M1, M2, and M3 line cards, and we have F1, F2, and F3 line cards, right? So F1 line card was originally the one which would support only layer 2 switching. It did not support layer 3 at all. M line card supported all the functionalities of layer 3 and some basic layer 2 functionalities as well, right? But slowly what Cisco did was they made the line cards compatible for layer 2 and layer 3 both. So gradually from F2 and F3 line card onwards, they do support layer 3 and layer 2 functionality. In fact, they do support Vxlan as well. So if a customer is looking for a Nexus 7K switch where he wants to use it for layer 2 and layer 3 both, then instead of having different categories of line cards, he can simply buy F3 line cards where it supports layer 2 and layer 3 both. However, from cost point of view, if you are really not having any specific use of layer 2 functionality and you are not using your Nexus 7K on, that is, aggregation layer, you're using it at the core switch where you want to just use it for layer 3, then you can simply buy M line cards, because M line cards are way cheaper as compared to F line cards, right? So M line cards support layer 3 functionality, so it can be used for doing your BGP, MPLS, OSPF, EIGRP, PBR, etc. All the layer 3 functions which we typically do on a L3 device. Whereas if you want to use your Nexus 7K for layer 2 and layer 3 both, then you can invest on a F3 line card, right? So if I go back and if I show you guys a quick comparison over here, between M and F line cards. So that's the different models of M line cards, guys. We have N7K M224, N7K M206, N7K M202, and these are the 7700 series. So Nexus 7700 supports M348 and M324. Right, these are the different models of M line cards. And if you go on F line cards, okay, before that, if I come on back on M line cards and I come a bit down, so they do support VPC. You can use them for configuring the VPC port channeling. Here, they support Vxlan and they support Fabric Path. So if you see, Fabric Path was originally by Cisco layer 2 full mesh solution, which is not widely accepted and adapted in production. So not very, like you can say, out of 100, only one customer probably might be using Fabric Path. So it's not that popular in production environment, but it does support Fabric Path. That's the only functionality which is not supported by by M line cards. I'm sorry, right? So they support Fabric Path, they support Vxlan, they support BGP, Evpn address families, Q and Q tunneling, MPLS configurations, OTV configurations, Lisp configurations. So more or less everything is supported by F3 line cards. These are the most advanced line cards we have. I'm sorry, M line cards. And if you go on F series of line cards over here, then again, F series of line cards also support all the functionalities. So if you see, they have got fixes, we support VPC, Fabric Path. With regards to layer 3 functionality, they can be used for OTV, Lisp, multicast, MPLS, Vxlan configurations. So all of the functionalities which were available earlier only in F line cards or only in M line cards are now made available in both, right? So to overcome that confusion from the customer's point of view, whether we should go with M or F, both the categories of line cards have now started supporting all the functionalities. Is that clear to everyone, guys? But earlier, the difference was that F line cards used to support only layer 2 and M line cards used to support only layer 3. But gradually, as the enhancements were made, both the line cards are now started supporting all the functionalities.
So if somebody had the old line card, would it still be either L2 or L3, or is that something they've done it at the firmware level?
No, it's on the hardware level. So if you have like F1 line card installed inside the chassis, it's never going to support layer 3. If you have M1 line card installed inside the chassis, it's never going to support Fabric Path or any other layer 2 functionalities. So if you have old line cards, you will have to replace them with the newer ones. It's a hardware limitation.
This option, we have it in 7K, 9K because of the modularity, right? I think.
It's not about 9K. This is just 7K we are talking about.
Yeah,
so 9K, we don't have this concept of M and F. Yeah.
Okay, but this is because of the modularity, right? This is a modular.
That's right. Because it's a modular switch, so we have options of using different modules on each slot.
Okay. So we can customize, right? How?
That's right. According to the requirement of the port density, port availability, and the bandwidth, we can accordingly choose the model of the line card. Now, here again, if you take a look at, guys, the model name, it says M224XP, it says M206FQ, M202CF, M348XP. So what is this meaning? What does this mean? So this has got a meaning. This has got a name. N7K means it's for Nexus 7000 series. M2 is the second generation of M line card, 24 number of ports. XP is the connector type. So XP stands for Qsfp plus connectors. 2, 3L. So 2 over here stands for the CPU generation. 3 is the number of fabric modules which are required. I shall come back to that. L is like it will require licenses for all the features which are supported, right? Similarly, if you see M206 is the number of ports. FQ is the Qsfp adapter, 40 gig adapters. 2, 3L, again, the same meaning. Here again, M202 means 2 ports. CFPs means your 100 gigabyte interfaces. 2L is the same. The 2 is the Intel CPU version. 2 is the fabric modules. Licenses are required. M348XP. So if you see XP, it means it is talking about Qsfp plus. If you see Q in the naming convention, then it is going to be Qsfps. If you say CF, then it's going to be 100 GB CFPs, right? So that's how you can identify from the name of the line card what type of ports it has got. So if you see FQ, it means it has got 40 GB, XP means 10 GB, CF means 100 GB. Is that clear to everyone, guys? So by reading the name of the line card, you should be able to understand what kind of ports and how many ports you're going to get.
In 06 means only 6 ports are there.
That's right. 06 means there are 6 ports. So if I come back over here, this guy 06, here you can see 6 ports of 40 GB QSFPs. Here you can see 02. So you have 2 ports of 100 GB or 40 GB. Oops. So depending on the model of the line card, guys, you will be able to identify the number of ports, the type of connector you are going to use for that particular line card. Similarly, we have for F series as well. So we have F248XP, F3, 12 FQ, so 12 ports of 40 GB, 6 ports of 100 GB, 48 ports of 10 GB, 24 ports of 40 GB, 12 ports of 100 GB, 30 ports of 100 GB. Any questions, anyone, guys?
So this speed is defined based upon the cable which supports the fiber cables.
So it is the port type. It's the port type. So if you see in this, yeah, if you see over here, if I just zoom in a bit, you can see these ports are a bit wider. So these are basically my QSFP ports, the 40 GB ones. You can see that it's the QSFP port. And these ports are the regular square ports, which are 10 gig SFP ports we have. So it depends on the model of the line card and what kind of port it has got. So here accordingly, you're going to insert the connector, the SFP connector, and the cable type would be fiber optic, of course, because it's 40 GB or 100 GB. If it's 10 GB, it can be a copper as well. But for 40 and 100 GB, it has to be fiber optic. So it does not depend on the cable type, it's the port type itself, which defines the speed.
Okay.
Is that yeah?
One question. So say we have 2 DCs and we want to extend that over 100 gig.
Mm-hmm.
What distance do these support? And for 100 gig?
No, so if it's 2 data centers, if it's geographically separated, like let us say one is in Singapore and the other one is in Australia, then you're not going to be able to do it directly. You will require dark fiber connectivity.
But if it's local, say in India, in Bangalore, you have 2 DCs. What's the distance? What's the distance?
So that depends on the cable type. So typically a long reach cable goes up to 300 meters. That's like 2 different buildings can be interconnected. Can be interconnected as DC-DR or DC-DC kind of setup itself. So typically a fiber optic cable.
Yeah, that depends upon the fiber, whether it is a MMP or SMP type of fiber that is going to use between those data centers.
Yes.
So LR optics.
Long reach.
Yeah.
Go with a long reach, single mode fiber. When it comes
LR reach can go up to 10 kilometers. Even longer also. You have ER optics, which are known as extra long. They can go 80 kilometers.
Okay, so is that on specific 100 gig? I was looking at. So
no, it's not specific to the port. It is specific to the optics or the cables you are using.
So port densities does not. Yeah, port density. The port bandwidth does not depend on that. The port typically, if you're trying to connect a back-to-back cable between 100 gig connectivity, then it has to be coming from your service provider, who is going to provide you a underlay connectivity, like between 2 different cities or within 1 city or 2 kilometers.
No, the issue I had was it was a DC, which is the buildings are not too far from each other. So obviously, to save cost, we thought I just wanted to know what the distance was if we wanted to connect 100 gig between the 2 buildings. I just wanted to know what the actual distance was that I could use. But yeah, no, that's fine. Thank you.
All right.
One easy solution will be to use the metro Ethernet circuit if the distance is not more. service provider can
Okay.
provide the Metro Ethernet link, which can support up to gig speed.
Yeah. Thank you.
All right.
Just also one more.
One question. In these Ape series line modules, we see the last series, that is 25E or 25, 23, 26, and 36. What does it mean? And it doesn't require any license?
No, it does require licenses. So they have not mentioned the letters over here, but it does require licenses. And this particular last, two things. This is the Intel CPU version, and this last numeric value stands for the number of fabric modules required. Okay, so I'll come to this point. I'll come to this, what exactly it means. And they have not mentioned about L and E over here. So typically Cisco used to express it as L base license and E as enhanced licenses, but then they have stopped mentioning about it in the naming convention, right? So they used to mention it earlier on the older models and while defining the name in the older series of line cards, but in the new series of line cards, they have stopped calling it out because, of course, we do require licenses for each and every functionality supported by Nexus OS.
Okay.
These 2 and 3, I'll come back to this. Let me just explain your fabric module concept. Any other question, guys?
Yeah, just one more question was, you showed the other slide. It had Vxlan Evpn, right? So what I want to understand is if I'm running Vxlan Evpn on the 7Ks, can I extend the Evpn into the ACI fabric? Is that possible?
You want to extend Evpn? You mean to say not extending Evpn? You want to say you want to extend layer 2 basically?
Or Vxlan, yeah. So can I extend Vxlan?
Yes, we can configure Vxlan between ACI and non-ACI fabric. So if you have non-ACI as your Nexus 9K or 7K, you can create a VTEP between that and ACI fabric. It is possible.
So you can extend the Vxlan into ACI, correct?
You can extend layer 2 by using Vxlan. Yes, you can configure VTEPs between ACI and a Nexus fabric.
Sure. Okay, thank you.
All right. So the next one, that's the line cards, guys. So the 2 modules which we have discussed is the Supervisor Engine and the line cards. And the next one is the fabric modules. So fabric modules with regards to Nexus 7K are basically the backplane which decides the throughput of the chassis. So if I draw a side view of Nexus 7K, let us say I'm drawing a side view, guys. So this is my motherboard. From the front of the chassis, that's the front, I'm inserting supervisor engines and I'm inserting the line cards. Okay, so these are my MNF line cards. Now, to interconnect this MNF line cards and to switch the traffic from one line card to another line card, to switch the traffic from one line card to another line card, the throughput of the chassis is actually determined by fabric module. So fabric modules are inserted from the rear of the chassis. Fabric modules are inserted from the rear of the chassis, and they have copper traces which interconnects all the line card slots with each other. So every fabric module will be interconnecting all the line cards and the supervisor engine with one another. So whenever the traffic needs to be switched from one line card to another line card, this traffic will be actually going through the copper traces and going outside the network. So the more number of fabric modules you have, the more number of copper traces you have, and the more number of copper traces you have, the more number of bandwidth can be delivered by the chassis. So fabric modules are the hardware which will actually help you decide the throughput which is going to be given by the chassis. Maximum you can have up to 6 fabric modules inserted in the chassis. And now if I come back over here, so the number over here which is mentioning it as 3, 2, 5, 5, 3, 5. So this is nothing but the number of fabric modules which are required for this particular line card to deliver the best throughput. So the best performance by this particular line card will be given only when you insert those many number of fabric modules inside the chassis. Did everyone understand this, guys? So every fabric module basically has got copper traces, which internally gets connected to each and every slot. So if I go and I click on fabric module over here, you can see I've come in the rear of the chassis, and these are the 6 fabric modules. These are the 6 fabric modules which are inserted in the rear of the chassis. 1, 2, 3, 4, 5, and 6. And this is one slot number 1. And here, if you see, these are the crossbar fabrics which get connected from the rear and interconnect all the slots with each other. So this fabric module will be inserted in the rear of the chassis, and it is going to interconnect all the line cards with one another. So whenever the traffic needs to go from one line card to another line card, these line cards will be switching the traffic within the chassis via fabric module. So more number of fabric module is equal to more number of copper traces is equal to more number of throughput. Right? So that's the third type of module we have on an Nexus 7K chassis, guys. So every Nexus 7K chassis, if I take an example of 7718, every Nexus 7K chassis is going to have these 3 types of modules. That is, from the front of the chassis, you will be having your line cards, your supervisor engine, and in the rear of the chassis, behind each fan tray, we are going to have 2 fabric modules each. All right. So just to write it down over here, Nexus 7004, no fabric modules. 7009, 10, and 18 support 5 fabric modules each maximum. 7702, there is no fabric module. 7706, 10, and 18 support 6 fabric modules each, right? So in 7000 series, we can have maximum number of fabric modules is 5. In 7700 series, maximum number of fabric modules, they have increased by 1. So it supports 6 fabric modules. Is this clear to everyone, guys? What is fabric module? What is IO module? And what is supervisor module?
Can you show 7710 backside of the 7710?
7710 rear. Okay, one sec. 7710. That's 7710, guys. From the rear of 7710, we have 3 fan trays. What do you want to take a look at it?
Actually, means under the fan tray are there. What are the items are there? Means these are the
below
fabric.
the fan tray?
Yeah, below the fan tray.
Yeah, these are the 6 fabric
modules.
modules. Right. And this fabric, after this fabric modules, there is nothing. There is motherboard, and then in the front it is line card.
Okay.
Yeah.
To insert the fabric module, does it need downtime or something?
No, it is all hot swappable. So everything is hot swappable, in fact. So even if your line cards go corrupt or they are not functional, or if your supervisor engine fails and you want to replace it or anything else, everything is hot swappable, guys. So in Nexus 7K, the hardware is completely hot swappable, which means in the running chassis itself, you can basically remove the line cards or remove the fabric module or remove the supervisor engine, and you can replace it with a new hardware. So everything is hot swappable, basically. There's no downtime required. Anyone else? Any questions? There's something on the chat from Himanshu. Fabric module is used to switch the traffic between different module type, or it's between any IO module, whether it is of same model or different model, same type or different type. Nothing to do with type, Himanshu. Basically, from one slot to another slot, whenever the traffic needs to be switched, it is going to go via fabric module, you can say. All right. So I think everyone is clear so far with the hardware of Nexus 7K. Let us now go on to the hardware of Nexus 9K.
Akash,
All right.
are you going to talk about the fabric module type 1, type 2, type 3, and BOQ as well?
I'm sorry, what?
BOQ, traffic forwarding between the 7K.
No. So basically, yeah. So basically, fabric module types. We had 5 fabric module types in 7000 series, but lately what we have seen is Cisco does not sell fabric type 1 module anymore. So if you try to place a bomb, if you try to place an order on Cisco CCW, they are going to push you for Fab 2 only. So whenever you're going to place an order for fabric modules, typically you're going to order yourself for fabric 2 in most of the cases. So you cannot say it is like end of sale, but they have stopped selling Fab 1 because of low bandwidth. So everyone now goes with Fab 2 only with regards to fabric module. Is that clear, guys? All right.
Yes.
Fabric bandwidth. So first, type 1 was having 55 Gbps of bandwidth, and type 2 was having 110 Gbps of bandwidth. So if you install 5 fabric modules in 7000 series, you are going to get 550 total bandwidth. So you can take a look at that over here on the chassis. I think it should come over here. So if you take a look at the throughput capacity of each and every chassis, this is the bandwidth per slot. So for 7004, there is no fabric module over there, but it does support 440 gig of bandwidth on per slot. That's maximum supported. And here you can see 550. So this is because one fabric module is going to give you 110 gig of bandwidth. So if you install 5 fabric modules, it's going to give you 550 throughput. 550 Gbps of bandwidth per slot. So overall, if you multiply times 18, you're going to get approximately 18 Tbps of bandwidth if it is your 7000 series. And in 7700 series, they have increased the bandwidth of the bandwidth of the fabric module. So here it gives you up to 2.8 Tbps of bandwidth per slot if you populate 6 fabric modules in the chassis, right? So that depends on how many fabric modules you are going to insert in the chassis. Accordingly, you're going to get the bandwidth. But overall, the total bandwidth given by the switch, you can see it over here. So in case of the smallest model is 7702, we get 5 Tbps of throughput by the chassis. In 7000 series, it's 1.92 Tbps of throughput, and the maximum you can get is 90 Tbps of throughput if it is 7718 switch. Clear, everyone, guys? Any questions from anyone else?
This uplink where we connect, actually, it's on the only on the supervisors. Is that the best practice?
Uplink
Between switches, I want to connect between 2 Nexus 7Ks.
That will be your IO modules, right? So let us assume that you have got 7704, 7702 or 7004, I'm sorry, and 7702. So from here, M line card, F line card, you're going to connect over here, M line card or F line card, like this. Supervisor engines are only for management purposes. So here you're going to take the management port from both the supervisor engines and you're going to connect it to your management switch for telnet or SSH purposes, right? And the data traffic will be going from one line card to another line card from one switch from the switch. So 48 port M line card, 48 port M line card, you're going to connect like this. Maybe you're going to configure a VPC or a port channel. Is that clear?
Yep. I was looking for this. Yeah.
All right. Okay, so the next one we have in the queue is the hardware of Nexus 9K, guys. Right. So 7000 series, which we took a look at, it has basically been designed for core layer, right? So typically, Nexus 7000 that you're going to see in production, it will be most of the times being used as a core switch, But in Nexus 9000 series of switches, what we have is we have got three families. We have got three different categories. So we have Nexus 9200 series, Nexus 9300 series, and Nexus 9500 series of switch. Now, because we have got three different families, these are all three different types of switches, which means 92 and 9300 are rack mount switches. They are rack mount switches, whereas 9500 is a modular switch, right? So in Nexus 9K, it's not that you can generalize Nexus 9K as a modular switch, or you can call it as a rack mount switch. It actually depends on the model of Nexus 9K, whether it's a rack mount switch or whether it is a modular switch. So if you consider Nexus 9200 series of switches, these are rack mount switches. When I say rack mount, this is very similar to 3850. Just like 3850 is 1 RU or 2 rack unit switch. Similarly, 9200 is also a 1 RU or 2 rack unit. Similarly, 9300 is also a 1 RU or 2 rack unit switch. Whereas 9500 is similar to Nexus 7K. It's a modular switch. So we have got different types of modules on it. So 92 and 9300, they don't have modules. They don't have supervisor engine. They don't have line cards. They don't have fabric modules. It's a modular switch. There's nothing fancy in it. So if you take a look at Nexus 92 or 9300, this is a 9300 switch, guys. 9372PX. So this is a 1 rack unit switch. You can see it's a 1 RU, and it looks very similar to a typical 3850 switch, which we use it for stack wise, right? So Nexus 93 and 9200 are 1 rack unit or 2 rack unit switches. If I go and do a compare model for these guys, so if I just say Nexus 9K compare models, nothing fancy in this. They are going to have like a typical rack unit switch. So let us go on 9200 series of switches. All right, so here we have 9200.
Can you look at the 93
right,
108?
So yes, I'll go to 93 as well. So see this 9216, 9272, these are all 1 rack unit, 2 rack unit switches. And typically they are used as top of the rack. So yesterday I told you guys what is top of the rack. What is top of the rack switch, guys? Anyone from yesterday can answer this question?
Access
Service
switch.
Access layer switch. Anyone else?
End of row switch.
No, it's not end of row. It's top of the
It will
rack.
connect to the end of the row to provide the core connectivity, but it is just on the top of the rack, connecting all the servers and other end devices on the access.
Is that all your leaf switches, right? Your leaves.
That's only in case if you are using it as ACI. So I'll come to that, Z. I'm trying to get what you're trying to say. Yes. So 9200, they do not support ACI. First of all, I'll come to that point as well. But 9200s are typically used as a top of the rack switch, guys, which means they are going to be connecting to the workstations. They're going to connect to your server farms. So all the servers running in your server farm are going to be connected to your 9200 on the top. So it is top of the rack switch. And then this is going to be connected to end of the row, maybe a Nexus 7K or maybe a Nexus 9500 series of switch, maybe, right? So typically 9200s are top of the rack switches where you're going to connect all the server farm devices, right? And that's the reason they are mentioning over here as top of the rack or access switch or aggregation as well if it's a 2-tier architecture. And these are all 1 rack unit or 2 rack unit. Now, one thing you can make a note over here is there's a small difference over here. So Nexus 9200 works in NXOS mode only. It works in NextOS mode only, or you can also call it as standalone mode. So standalone mode or Nexus mode means it will be configured and managed just like any other regular CLI switch. But 93 and 9500, they do support Nexus OS operating system, as well as they also can be used for ACI. They also can be used for ACI, application centric infrastructure. We are going to see this in module number 2. You can just make a note of it for now. So Nexus 93 and 9500, they can either be used as a Nexus switch, like a regular CLI switch, or you can run it in ACI mode for Cisco software defined networking. So that depends on what operating system you install inside the switch. If you're installing NX OS, then it's going to work like a regular CLI switch. If you're installing ACI operating system, then it's going to be used for Cisco SDN. Right? Nexus 9200 does not support ACI.
So if it's not running in NX OS and if it's running in ACI mode, what is that called?
So that's basically software defined networking solution. So it's basically controller based management. You will be managing controller.
So I'm guessing it's just the image that you run on it, right? So it's either you're running a NX OS image or you're running an ACI, correct?
That's right. So you can either set your boot variable to Nexus OS, or you can set your boot variable to ACI. It cannot run in both the modes at the same time. Is this clear to everyone, guys? All right, so that's 9200 switch, which supports only NX OS. If you go 9300, so if you take a look at Nexus 9300 compare models, so 9300 has got like 3 different flavors, guys. We have 9300 10 gig switches, we have up to 25 gig, and we have 100 gig switches as well, right? 100 or so these are the 100 gig switches. These are 10 gig switches. So if you take a look at 9300, which supports up to 25 GB, you can see they have always also 1 rack in it, 2 rack in it, right? And again, if I come down, they should have mentioned it somewhere over here. So it supports Nexus OS as well as ACI. So either you can use it for Nexus, or you can use it for ACI. Okay. Similarly, if I go in 9300 for 100 gig, they can be used in both the modes, either in Nexus mode or ACI mode. So depending on the model of the switch, we can basically either use it for Nexus only, or we can use it for Nexus and ACI.
Just one more question. Say if you're running NX OS switches, and then you want them compatible with spine and leaf architecture, what happens to the configuration? Is there a tool that we can turn the configurations of NX OS to support spine and leaf architecture? Or
when you say spine and leaf architecture, so spine and leaf architecture comes when you're talking about Vxlan specifically, or you're running the switch in ACI. So if you're running the switch in Nexus OS and you're going to use it in Vxlan, then there's like leaf and spine concept, but there's no tool as such where we can convert the configuration, or where we can.
So I guess you would just configure it from the Apex, right?
From the Apex controller.
Okay.
That's right.
Okay. That's.
Actually, the OS will not depend upon the spine, or like NX OS will work in spine leaf also, and spine leaf work in a two-tier architecture as well as in ACI also. So before going to mount in your device into ACI architecture or two-tier, before that you need to check what operating system you need. If ACI, then ACI OS you required. Before the mounting the device with the spine, you have to upload the ACI OS. Then spine will the Epic will discover your device. And if you talk about the two-tier architecture, then NX OS will require.
No, that's fine. It's only that. No, I understand that point, but sometimes we
go. I think I'll be there to answer the query. Maybe if you have question, you can answer it. You can ask the question, or you can leave the questions to answer by me. Zia, is your question answered, or are you still looking for?
Yeah. No, that's fine. It's sometimes we will go into environments where the customer's already running NX OS, and we're trying to implement the ACI architecture. So in that case, we have to We have to
Right.
turn.
So if you want to move the switch from ACI to NXOS or vice versa, you'll have to
Yes.
reimage it. And there's no
Yeah.
tool which can do the configuration, convert the configuration from
Okay.
ACI to NXOS. It has to be done manually.
Manual. Okay, thank you.
So Akash, I have a question. I have a question here. So if you are running a switch with NXOS or in a standalone mode, and I want to move it to an environment where ACI is used, just say we have two parts in our data center. One is standalone and one is ACI. And we are transiting from the standalone to ACI. Do I need to do something on the standalone switches so that they are compatible with the ACI?
You'll have to reimage it. So first is you should verify if the hardware is compatible. Of course, it has to be Nexus 9300 switch or 9500. You'll have to reimage the switch.
So reimage means, does it mean that I have to upgrade or downgrade BIOS on that?
No need to do the BIOS part, but you need to download the image. So if I show you.
So they are just having a different image. If I load a ACI image, it will be working in a ACI environment.
It will be working as a ACI. Yes, it will work as ACI. If you download an NXOS image, it is going to be running in a standalone mode.
Okay, so now I mean, with the new releases coming in, which are 64-bit, I mean, does that we have any information? How does that work? Or I mean, ACI is also going to support 64-bit images, or no?
64-bit images. I did not quite understood that part.
So currently, the NXOS OS is 32-bit. I mean, at least till the release, last release.
For ACI, I don't see that part. Maybe I'll have to double check from my side, but I'm pretty unsure about whether it is 64-bit or not. So this is the software which I was talking about. So if you're trying to upgrade the switch, you need to download here this particular part, ACI 14.2. So that's basically for 4.2 series of ACI. Epic controller will be on 4.2 and your switches will be on 14.2. So if the switch is in standalone mode, you need to download the bin file, upload it via TFTP or bootable pen drive.
Got it. Sorry. So this ACI controller, right? What is that? Is it a switch or it's a Linux system or something?
It's a server. It's a Cisco CC server. Let us not go in that direction. We'll actually take a look at the complete module, right? We have ACI module, that's module number 2. So we'll be covering the Nexus 9K hardware again over there. And I'll be again explaining the concept of ACI and the controller and the architecture of leaf and spine in there. For now, for now, I just want to talk about using Nexus 9K in NXOS mode, guys. Right?
We need any license for this conversion?
Licenses from ACI, yes, we do. We have smart licensing over there. And for Nexus also, we require licenses. However, for Nexus, the licenses are feature-based license. So when we will start talking about the features, VPC, VDC, OTV, Vxlan, I will let you guys know exactly which licenses are required when.
Okay.
Any other questions, guys? Let me take a look at the chat window. Okay, there's a question from Rafi. Rafuddin. So yeah, this is a kind of demo, but it's more or less like a daily class as well. I just wanted to give you guys the feeling of how a regular class goes on. So this is how a regular class goes on, but yeah, it's a demo class. Rafuddin. All right. All right, so 9200, 9300, I think everyone is clear about that. So it's a rack unit switch. We don't have any modules over there. This is a demo class, Rafuddin. It is a demo class, right? I'll be pausing now and then I'll be opening up the session for question and answer if anyone has got any questions. Right, 92 and 9300, these are like your regular rack mount switches with 1 RU or 2 rack unit. And then we have 9500 series, guys. So 9500 series is very similar to Nexus 7K. So here also we have got different types of modules. We have supervisor module, we have IO module, we have fabric module, and we have additional module known as system controller. Okay, so we have got like 4 different types of modules over here. We have soup, IO, fabric, and system controller. Supervisor module over here is again categorized into 2 types: soup A plus, B, and B plus. Just like in Nexus 7K, we have soup 1, 2, 3, soup 1, 2, 2E, and 3E. Similarly, here we have A plus, B plus. IO modules are not categorized as M or F, but it is categorized as 10 GB, 40 GB, and 100 GB, right? So IO modules are categorized into 10, 40, or 100 GB of line card. Fabric modules, we don't have any types. These are again being used for the same purposes. That is to provide the bandwidth for the fabric, for the switch. System controllers is an additional module. So before I jump on system controller, let us just take a look at 9500, guys. So Nexus 9500. Now this one is 9500-08. So 9500 are of 3 types. We have 9504, 08, and 16. Right. So there are like 3 different models of 9500 series: 9504, 9508, 9516. And if I go back on the switch, that's how 9500 looks like. So we have got 9508, which means 8 slots. So we have slot number 1 to slot number 8, where we are inserting the line cards. And then we have 2 additional slots where we are inserting the supervisor module. So if you take a look over here, we have got 10 GB line cards, 40 GB line cards. These are 100 GB CSP line cards. So 3 types of line cards, 10, 100, and 40. Here we have supervisor module. If I zoom in a bit, it is soup A. You can see it's Nexus 9K soup A engine. Now, can anyone tell me the difference over here between 9508, between 9Ks and 7K hardware from the front view? What is the difference you guys can see? Anyone?
It's 8-port switch. 8 sesh.
The position of soup engine, they are at the module 8, not in between.
That's right. The position of the supervisor engine, it's in the last of the modules. So in 7Ks, the supervisors are placed in middle of the chassis, right? Depending on the model of the 7K, it can either come in the in middle or in the start. But in 9500, they have just placed the supervisor engine in the last. That's a small difference which you can see just by looking at the chassis. And then in the rear of the chassis, you are going to see the fan trays. And behind each fan trays, you're going to see the fabric module. So just like Nexus 7000, here also we have got 6 fabric modules, two fabric modules behind each fan tray, right? And then in addition to fabric modules, IO modules, and supervisor modules, one additional hardware we have is system controller. One additional hardware we have is system controller. So what is a system controller, guys? This is not in Nexus 7K. So Nexus 7K does not have system controller. We have system controller in Nexus 9K only. So what is a system controller? Anyone? All right. The system controller is an additional hardware which is responsible for the hardware management of the chassis. The system controller basically deals with the multiple things, in fact. So system controller verifies the power supply of the chassis. It verifies the temperature of the chassis. The fan trays are functional or not, whether the IO modules are functional or not, right? The system controller basically verifies and makes sure that the hardware of the chassis is running fine. If anything is wrong with the hardware, if something is wrong with the hardware, then it is going to send a signal to your supervisor engine that the hardware is inoperable. So if your power supply is not functioning fine, or temperature of the chassis is high, or if the fan trays are not in operational state, the system controller will send a signal to your supervisor engine that this particular hardware has failed. So all these tasks were taken care by the supervisor engine in Nexus 7K. But in Nexus 9K, these tasks are offloaded from supervisor engine and they are given to the system controller. So we have additional hardware over here. Is that clear to everyone, guys? There's a question in the chat. What is the method to determine whether soup card, where the soup card to be inserted? Oh, for that you should be having a data sheet with you, Himanshu, to take a look at the slots which are reserved for Supervisor Engine. You should be having the hardware clarity on that, which slots are dedicated for Supervisor Engine, because just by looking at the chassis, you are not going to get that clarity that, okay, these slots are for soup. But typically when you order the chassis, Himanshu, it's already done for you. Okay, so chassis always gets shipped with the modules inserted. But just in case, yeah, if you're doing it yourself, then you should be aware about the slots, especially in Nexus 7K, because for Nexus 9K, they are having a dedicated slots in the end. But for 7K, we don't have a dedicated slot.
In this, which IO module is 100G? In this,
this one, the second last. Let me zoom in. This guy, you can see the wider ports. These are the 100 gig ports, CFP.
okay, thank you.
The medium ones are the 40 gig and the regular ones are RJ45 and SFPs.
So 9516 is the biggest switch in the Nexus family.
That's right. So we have 9504, 9508, and 9516. 9516 being the biggest one. And in this also, if you see, the Supervisor Engines are in the last, all the line cards on the top, and fabric modules in the rear. Is everyone clear, guys, with regards to the hardware of Nexus 9K and Nexus 7K? Okay, system controllers also will be working in active standby mode, just like your Supervisor Engine. So we'll be having two system controllers inserted in the chassis from the rear, and it will be in active standby mode. It will not be in active mode.
Just one question on the fabric modules. The last, if you can just zoom in, is it the last 4 ports? Are they 100 gig? So
here, these are 40 gigs.
The 40 gig.
Yeah, these are the 40 gigs. So this particular line card is giving you 4 ports of 40 GB and 48 ports of 10 GB.
10, okay. And so these don't support 100?
This particular line card does not support 100.
Okay.
You can buy a 100 gig line card and insert it inside the chassis.
Okay.
So it's a modular switch. It depends what line cards you insert.
Yeah, that's fine. I think at the top you have maybe the top ones.
These are also 40 GB. Yeah, these are all 40 GBs.
Yeah.
100 GBs are much wider than this.
Yeah.
And typically we don't get these many 100 gig ports. So maximum 100 gig ports you can get is maybe 30. That is one of the line cards which gives you 30 ports of 100 gig.
Yeah, I mean most customers we go to now they just 100 gig. They're not even 40 gigs.
Right. So you can always take a look at the models from here. Cisco Nexus 9500 compare models, and here you can see we have 100 gig modules. So from here you can see the different models which provide you 100 gig ports. Maximum you get is 36 ports of 100 gig.
Okay. The 93.
Anyone?
Can you
Any
just,
questions? Yeah.
Yeah, on the 93.108 TC. Yeah, that one there. How many 100 gig can this support? 6. Okay, yeah, that's fine.
Yeah, here.
Yeah, 6, either 600 or 640. This is the fixed. Okay, thank you.
Hello, Ashish, is there any technology, let's suppose our core switch or spine have loaded, means all ports are occupied. So can I extend like earlier we were fabric extended, we are using fax for our means access switches. But is there any technology to extend our interface at core level switch like 9K or 7K?
The same faxes. So faxes can be connected to your 9Ks as well. You can connect your faxes to Nexus 9K. Although it is not typically done if you're using 9K for core functionality. But if you're using your 9200 or 9300 series of switches at aggregation layer, then you can connect them to your fabric extenders for port extending. So that can be done.
No, I'm asking about the core layer extension, core layer port extension, not access layer. Like suppose my core switch is 950, total 286 266 ports are there. If we have 40 geo and so like all the ports are occupied, and now I want one more line card. So there is no possibility to insert. All the modules are occupied. So in that case, will I have to go for new chassis, or I can add one additional device or a fabric extended? Is it possible or not?
You mean to say that can you connect your Nexus 2K fabric extenders to 9500 chassis or not?
Yeah, some kind of got correct.
Yes, I don't see a limitation. Maybe we can quickly take a look at it. But 9Ks are 2Ks. 9Ks can act as a parent for a Nexus 2K for sure. But specifically to 9500, if it's not compatible, I will have to take a look at that. But I don't think so. It must be a limitation. But now I have personally configured a Nexus 2K for 9300 in ACI as well as in Nexus OS mode, so it works perfectly fine. But for 9500, can we connect a Nexus 2K fabric extended to it? Maybe I can take a look at that. I don't think it should be a limitation because it does work for 9300 at least, so it should work for 9500 as well.
Again, if it's, can you connect it if it's a leaf switch? So can you connect the 2Ks onto leafs? So say you got 90. Yep.
Yes, of course. For ACI, we can. We can connect a fabric extender to a Nexus 9K running in as a ACI leaf switch.
Oh, excellent. Thank you.
Nusrat, for 9500, let me check a data sheet and get back to you if it's compatible or it has a limitation.
Okay, thanks.
Right. Any other questions, guys? All right. Let me stop the recording over here.